This right here is a A-level maths question. And as you can see, it's worth 5 marks, which means if you were leaving that on the table in an exam, that is a decent chunk of marks taken off your grade. And I'm sure you've been in this situation as well. Picture this, you're in an exam, it's late in the paper, the clock's ticking, and you're there looking at this question thinking, okay, where do I even start here? And you sort of just rush into it. And after you rush into it, there's nothing there. You've got the answer wrong. And you're thinking, wow, that was a waste of time. I just wish I had a system for working this out. And you're confused as well because you've done all the past papers, right? You've revised all the past papers, you've done the volume, and yet something has popped up that has completely caught you off guard. And so the fix isn't just more past papers, though volume is very important. But the fix actually lies in the underlying methodology of a book that was published more than 2,000 years ago. And so in this video, I'm not going to give you the method for this problem itself, but what I am going to do is give you one of the most concrete methodologies out there for how to answer the question, where do I even begin when you're faced with a question like this? Euclid's Elements was for many years a foundational text that nearly everyone studying maths had to study. And it was less for the fact that it was just a geometry textbook, even though that was obviously useful, but it's more for the principles in it that were so universal to so many different fields. So what Euclid basically did was, he built the foundations for the maths itself. So he started off with axioms, things that were so self-evident, and then he built from that. Okay, so it wasn't, again, it was a geometry textbook, but it was more about the underlying principles of seeing something as true, okay, as obviously true, and then building upon that. So what are these principles really? Now, if you wanted to break it down into 3 principles, you could do it like this. Obviously, there's other problem-solving frameworks, but this really is the core. So in essence, what we've got is principle 1, the foundational principle, and it encapsulates the other 2. And that is that we have one fixed structure for every problem. It's basically the idea that whenever you're faced with a problem, you can apply the same fixed structure. Okay, so what goes inside that structure? Well, what goes inside that structure is principle 1, which is starting off from foundations. Okay, so start off with what you see to be evidently true. And then principle 2 is basically to justify every step going forward with what came before. Okay, so we are using principle 1 with the foundations to lay the core foundations and then build up from that, right? That is eventually how we arrive at an answer. Now again, this sounds very basic, but it's very easy in an exam to forget how these principles are designed to be used and how important they are, because oftentimes you'll just see a question, just jump into random pieces of information and try to figure out an answer from there. What this achieves for us is this gives us a consolidated kind of framework that we can organize our brains into. And that single structure, again, is not just applicable to maths. And one of the biggest examples of this is Abraham Lincoln, where effectively he studied this book and he'd apply it to his law practice. Okay, so this is how he refined himself into a better lawyer, because he was basically starting from first principles and deriving conclusions from those principles. Okay, so it was a systematic way of thinking. So if this structure can do all that, let's see how we can apply it now to our question in the beginning. Alright guys, so here we are in the weeds doing this question. So what we've got here, okay, is this diagram. Okay, now what I'm going to do is I'm going to assume that we've already answered A and B because I don't want this to take too long. I think C is going to demonstrate this quite well. Just disclaimer, Euclid wasn't around when calculus was invented, so I'm not applying the geometry here. What I am trying to apply is the first levels thinking that you can use and adapt to answer questions as well. So we are told to use integration, okay, to find the area of R here, okay? So it's a bit weird because when you first see this, you might be tempted to just rush in, maybe do something where you do L1 minus L2, you do like a Y integration or something kind of weird. But what I want you to do is step back and just look at this from a bird's eye view and see, as in principle 1, what can we set as our foundations here. Alright, so as per what we know already. Okay. Let me do it in red. Okay. We know that y is equal to minus 12x plus 48. Okay, and that is L1. We know that L2, as you can see over here, we have an equation y is equal to 8x. Okay, so we have two lines here. Okay, that's part of our foundation. We have two lines. Okay, L1 and L2. Okay, cool. Now what else? Well, we are told to find this area. So let's see, okay, what does this area actually encompass? Well, what we have is we have our curve over here, okay, which is y is equal to 8x minus x to the power 5 over 2. That's part of our foundation. Part of our foundation as well is that what we have here is a triangle, okay? So we have a triangle that is being held up by L2 and L1. And inside this triangle, we have this. So the question becomes, well, okay, well, the shaded area of R, what does that encompass? Well, the shaded area of R, okay, I'm simply going to say, in fact, let me just make this part 1. And obviously in an exam, like, you don't have to write it out like this, but it's a good way to just train your brain to think, right? And again, this isn't anything novel or like new from the get-go. But what we're doing here is basically putting a label on a type of thinking that is very easy to forget, right, under exam pressure. Okay, so it's not this is some kind of unique, this is like a unique way of thinking, but what this does do is it's designed to train your brain to really think like this. Okay, so either R is area of the triangle. Okay, it must be based off the foundations that we have here. Okay, that R is going to have to be the triangle, area of the triangle, minus area under the curve. Now let's apply the second principle here. Okay, justify each step. Okay, so we've used our foundations to basically create a blueprint here, right? And that was formulated from all the knowns of that question. So now we have to justify each step. So the question becomes area of a triangle minus area under a curve. How are we going to justify each step to get to this answer? Well, we take a look at the area of a triangle. What do we need to know? Standard area of a triangle is half base times height, right? That is the standard area of a triangle. And so we need to ask ourselves, where can we find a base and where can we find a height? What values from our foundation is going to help us to find the base and find the height? Well, we know for any triangle that base is going to be this over here. Okay, and so what we can do here, guys, is we can utilize our foundation, knowing the fact that the x coordinate of A is 4, okay, we have 4, 0 there. That must mean that our base, okay, is going to equal 4 units. Now, what about height? How do we get the height from the foundations we laid before? Okay, so we know from first principles that we can get 4, but the height now is going to be here. Okay, so how do we do that? Well, we have L2, we have L1. Can we find the height from these? And the answer is yes. We can do that by finding the intersection between L2 and L1. Okay, so what does that tell me? And again, I wouldn't write this all in an exam, but this is what your mental model should be like. It's going to be 4 times y value of the intersection of L1 and L2. Okay, so the question becomes, we've got our knowns here, but we do have an unknown here. Okay, so what is the y value of the intersection of L1 and L2? So what I'm going to do now is I'm going to skip through this bit because for the purposes of the video, it's just computational, right? I really want to go into the principles of this. So I'll do it quickly and then we'll link up at the end. Alright guys, so as you can see, our intersection is 12 over 5, 96 over 5. Okay, so now, again, going from the principle of justifying each step, what does that mean in terms of our area of a triangle, specifically the height? Well, if we've got 12 over 5, okay, 96 over 5, okay, that must necessarily mean, okay, that considering it follows a pattern like this, okay, 12 over 5 on the x, 96 over 5 on the y, that our height, okay, is going to be 96 over 5, okay? So now we have the raw material to work out the area of our triangle. So let me go ahead and do that quick. Alright guys, so as you can see, the area of our triangle is now 192 over 5, okay? So that basically solves the first bit of the blueprint. And now what about the area under the curve? Well, we've actually done all the hard bit, right? Because we know, again, this is just computational at this point, that our y curve, okay, our curve here is y is equal to 8x minus x to the power 5 of 2, which means we just need to do a basic integration to solve that, okay, to find this bit. Okay, so there's not too much thinking here. Now it's just computation. So let's go ahead and do that. Alright guys, as you can see, this is purely computational, which is the integral between 0 and 4, okay, of our curve. Okay, we get 192 over 7. No real thinking or deriving needed there. It's simply just computational. So as a result, we can say that our total area, okay, again, going from our blueprints, triangle, area under the curve, that's simply going to equal 192 over 5 minus 192 over 7, which gives us 384, okay, over 35 units squared, okay? That's going to be the final answer there. Now let's tie this all together. Remember that fixed structure? Now here's the checklist that you can use so that whenever you're stuck on a question where you're thinking, where do I even start? Use this and hopefully it helps you out a little bit. Number 1, what am I actually asked? Number 2, what do I already know? Number 3, what can I build from that? 4, work it. Justify each step in your head. 5, state the answer cleanly. And look, this seems really, really basic, but all this is designed to do is try to give you some underlying principles that you can carry with, so that when you're trying to find an answer, this doesn't mean you're going to find an answer, super easily every time, but what it does do is it gives you an underlying framework from which you can build from, and it's basically universal. Now if you're going into A-levels and you're looking for some problems that you can test this on, make sure to click the link below. From there you can find a fully compiled worksheet of all the exam questions that you'll find for AS, so that's basically year 1, and that is completely for free.